And welcome to Module 1.4C, the brain divided. Here's your vocab, pause if you need to. So first, we're just going to take a little review into what neuroplasticity means. This is just the brain's ability to adapt and change. We mentioned in this mod when we discussed this that a blind person who uses their fingers to read Braille, their brain expands that portion of the brain devoted to sensation of touch in their fingers into that visual cortex. So that's an example of plasticity. How is the brain able to do this? That is something called neurogenesis. Neurogenesis is the formation of new neurons. So these are baby neurons. They're considered master stem cells. What helps us grow neurons? Sleep, exercise, and non-stressful stimulating environments all help us grow more brain, neurogenesis. So what are stem cells? These are cells that develop into any type of brain cell. So they can navigate to different parts of the brain, become different brain cell types. And so surgeons wonder if someday this could be useful to have stem cells regenerate parts of the brain that have been damaged or injured. When we look at the brain, we know, I'm sure you've heard, the left and the right hemisphere, and there's a lot of misconceptions about this, but the idea that each side of the hemisphere, there are different functions that are predominant in one or the other is called lateralization. So for example, math tasks, we see more blood flow to the left hemisphere. Perceptual tasks, we see more blood flow to the right. If you look over here, this kind of just gives you some basics. Some key ones that come up are creativity, right brain, spatial ability, context. So in terms of language is over here in the left hemisphere, speech language comprehension, but context, so like nuance or just different like tone and things like that, that seems to be in the right hemisphere. So something important I want you to understand is that the left and the right really do work together. It is not like, oh, your right brain or your left brain. That's a misconception. It's both of these parts of the brain work together. And there is something called the corpus callosum that connects the two hemispheres. So the trick for this part of the brain is think of a corpse laying across the top of the two hemispheres, corpus callosum, because it is the bridge that it connects the left and the right hemisphere. So how does this lateralization work? If you look over here, so they're looking at a pencil. So let me just let me show you with my face because I feel like that's easier. So my left hand and my left leg are being controlled by my right hemisphere motor cortex, and my right arm and right leg are being controlled by my left. The information in my left eye is going to the right hemisphere and vice versa. Okay, and again, the bridge of the corpus callosum is what's allowing the communication to happen on both sides. Here are some facts about both hemispheres. I kind of discussed these in the other one, but pause here to take any notes. So there were several patients who, due to medications not working for epilepsy at the time, which now we have much different medication, some people, they severed their corpus callosum in order to resolve severe epilepsy issues. And these people were considered split brain patients. This means that their corpus callosum was severed, so the communication between the right and left hemisphere was not happening in the normal way. So Michael Gazzaniga, the psychologist, researched this using what is known as the heart study. And here we go. So the heart study, you would stare at the dot, and if you see here on the left side, they're seeing HE, and on the right side, they're seeing art. So we know that HE is going over here, the right side, and ART is going over here to the left side. And the left brain is where we speak words. So when asked, so they're staring at the dot, the information is going to go to the two different parts of the brain. When they're staring at the dot and they're asked the question, what word did you see? They're only able to speak the word art because right eye goes to left hemisphere, and that's the speaking part of the brain. But if they are asked to point with their left hand, okay, so left hand is controlled by right hemisphere. It says point with your left hand to the word you saw. That's when they point to he. So this is wild. This tells us that our brain is processing information even though we're not consciously aware. The person's asked what word did they see? They said art. But when they're asked to point with this part of their body, they're pointing to he. And that's because the corpus callosum is severed, so the communication isn't happening. So in a person who doesn't have their corpus callosum severed, you would not be able to have these same results. But what this shows us is how the brain is able to work, and even on that unconscious level that we're not aware of. Takeaways: the brain is flexible and adaptable, and that is thanks to neurogenesis. Stem cells can develop into any type of brain cell and perhaps in the future be used to repair damage. The corpus callosum, think of a corpse laying across both hemispheres, connecting the two like a bridge. Remember, spoken language is from the left hemisphere. The split brain patient, make sure you understand that heart study. And that wraps up Mod 1.4c. I'll see you in class.